Hello, it's James Governor, co-founder of RedMonk, and we're here for another edition of What Is, How To. And today we're going to be looking at unit testing. Really, what is unit testing and how can you improve your test coverage? Specifically, in this case, in Java, our guest today is Andy Piper, VP of Engineering at DiffBlue. So hi, Andy, thanks for joining us.
Hi, James.
And obviously, you've got a lot of experience in and around unit testing, test coverage, and automated testing in the enterprise. And I'd love to know what exactly is unit testing and how can you improve your coverage? So yeah, I'd love to crack on with the presentation.
Brilliant, thanks, James. And it's a really great question as well, because I interview a lot of people, and it's surprising how many people really don't know. They confuse unit testing with other things. So maybe if I dive straight in onto what unit testing actually is, or what I say it is. So it's slightly controversial subject, testing, because people are very opinionated about testing. So these are my opinions, but they're the right opinions, obviously, because they come from me.
There you go. That's the right kind of opinionatedness, is that you're...
So apologies if you disagree with the facts, anyone who's watching, but there we go. All right. So what is unit testing? So it's what it says on the tin. It's writing tests for individual units of code. And what do we mean by individual units of code? So we mean specific components in isolation. So that might be a class in Java or even an individual method perhaps. But the key is that it's small, it's standalone, and you're just flexing the muscles of that functionality, so to speak, through simple tests. One of the reasons we do that is because it's in a very simple environment. It's abstract. It's far removed from customers. It's far removed from danger of bugs in production code. Mm-hmm. And it's easy to reason about what the code should or shouldn't do, because you've got that simplicity. You don't have lots of moving parts. You're not trying to coordinate this thing with this other thing and make sure they're all working together before you can write the test. It's simple, it's straightforward, it does what it said on the tin.
And is unit testing part of this phenomenon we keep hearing about, shifting testing left?
Absolutely. You're stealing my thunder here, James. But you're exactly right. So unit testing is shifting left. We're doing testing front-ended at the beginning of the development process. So we're trying to get testing as close to development as possible. And that's what we mean essentially by shifting left. And that's a cheap thing to do. That's a safe thing to do because there's a number of reasons. So one is, it's simple. Unit tests are simple. You're testing small parts of code. It's simple to reason about. But also, the developers have context. They know what they're trying to do. They know what the intent of the code is. They can easily construct tests that express that intent because it's all right there in front of them. They're in the process of development. The further you get away from that, as you get into, sort of committed code that's a few weeks old, or code that's in the hands of a customer, the harder that gets, and the more expensive it gets, and the more risky it gets, because obviously bugs can be reputationally problematic for software companies. They can be business breaking, essentially. So right. It's better to catch things early in that respect. So to speak. You might ask yourself, okay, so that sounds great. Why do people not do it? And one of the reasons is it appears expensive at the time. It requires, unit testing is essentially development. So you're writing code in the same language as your sort of functionality, and it takes some skill, it takes some development, and that development is an expense. So development managers might be putting developers under pressure to crack out the functionality that they need, and not doing unit testing seems like a good way of cutting a corner on that time thing. So that's primarily the main reason people don't do it. But also, often developers don't like doing it, at least not at first. It's quite time consuming. It can be quite tedious and repetitive. And there's a certain amount of skill in doing it. And if you're not familiar with something, you tend to avoid it. So
Right.
it's that sort of thought process going on. And then I suppose the final point to make is developers love seeing things working. They love seeing things in action. I've called this giving them the dopamine high. So they love seeing their end-to-end functionality.
Mean time to dopamine is sort of an underappreciated important thing in terms of software developers and how they work. And I think that's a really interesting thing that you're saying. It can seem expensive, and it can seem like something developers don't want to do, but if you give them that dopamine experience of knowing that something is working, then that can perhaps ameliorate some of those other concerns that you mentioned.
Absolutely. If you can do that, that would be great. I suppose one of the things I'm arguing is they sort of shoot straight for the end point because they get more of a response from that. So the typical scenario is for people to write what they call sort of end-to-end tests, where they're basically testing the whole thing together. And that's great when it works, but it's awful when it doesn't. What happens if you don't do unit testing? Well, it's obvious, really. You get bugs and regression, and those are expensive to fix, both in terms of time and money, but more importantly, in terms of reputation and also opportunity costs. If you're fixing bugs for customers, you can't be working on the next big thing or the next great thing, and that's problematic for businesses. So, yeah.
Can you talk a bit about? Sorry to interrupt. A bit about organizational maturity, because historically, as you've said, we perhaps had a different group that was doing testing.
Yeah.
Perhaps we heaven forfend that we were doing waterfall and working with outsourcing, where the development was happening overseas or something, with a big code base. I mean, in terms of the customers or the people that you're talking to, what sort of maturity levels do we have around organizations having, and I may be completely getting out of sequence here, but what sort of maturity do you see? How well understood is the need for unit testing and test coverage? And what do you see in terms of organizational maturity there?
Yeah, good question. So I think the answer of what do I see in terms of organizational maturity, a very broad range from no testing at all to full fat TDD, BDD, all the rest of it. So
right.
Very, very broad, and not necessarily, you might think it's the smaller, more agile environments that are, better placed in that regard. Not necessarily, large organizations doing things very well as well. Large organizations doing things very badly. I think in terms of seeing the need, I haven't come across anyone who doesn't see the need. I think it's always, they've always made a trade-off, right? It's not that they don't value testing, it's just that they've made a trade-off and said, right, I've just got to crack on and ship this thing, and I'm gonna, miss out the testing part, as it were, or some of the testing part. Okay. And I guess that comes to this sort of second point about legacy, because legacy is a big problem here. That a lot of the code that doesn't have tests is the code that's in the past, the mistakes of the past, and everybody's trying to deal with those mistakes. All code is legacy a week later sort of thing, but it's part of that process where legacy code they've made some taken some shortcuts as they write it, and then you have to deal with that tech debt at some point if you want to maintain it in some way. Mm-hmm. And certainly when we interviewed people, all developers said that if you've got unit tests, much easier to change code. You haven't broken something. Okay. You can make those changes easily. If you don't have tests, how do you know? It's just impossible to say. Back to stealing my thunder, James. What happens if you do write unit tests? Well, essentially you're shifting left, right? So you're catching problems early in the process. And that just, it's sort of this golden moment. If you can catch problems early, then you've won on all levels, sort of thing. So it's just so important to do that. And this is why, another thing I talk to people about, which they don't really often don't really realize, is this notion of the testing pyramid, and you have unit tests at the bottom, and then sort of very complicated deployment type tests at the top. Mm-hmm. And that gives you an indication of the volume of tests that you should be writing. So a pyramid, very fat at the bottom, narrow at the top. You should be writing lots of unit tests to start with, very few integration tests, and that's because you can catch many more problems early if you do it that way. Okay. If you're not doing enough at the bottom, then you're not catching problems early.
Yeah, I mean, as a father of three, I often think of parenting as basically risk management, and you want to catch problems early. Yeah. So before the bad thing happens, you want to head it off. If there's something on the side that's going to fall on someone's head, or like let's not wait till after the problem happens before we try and remediate it. So this one definitely resonates with me.
Yes, absolutely. And I think everybody will acknowledge this is the right approach. It's just events overtake them, as it were. So yeah. Okay, so we sort of explored the pros and cons. Well, what happens if you could do this automatically? And obviously I work for a software company, and this is what we do. We write unit tests automatically. And there's a lot of reasons why you might why that's a good thing. So it takes away the tedium. It takes away this time constraint where you're sort of inclined to cut corners. Mm-hmm. It means you can focus more on actually writing code. And so, if you could write unit tests automatically, that would be a really good thing. I hope you would agree. So,
I mean, this isn't just boilerplate. I mean, this is
I know exactly. So, and there are a lot of tools out there that do boilerplate, but the user is then still expected to do more. Mm-hmm. So no, we're actually talking about good unit tests. So unit tests that a human might say, actually, that looks pretty good to me. So I was going to switch to a demo straight over, if that's okay, James.
How to is always the best part.
Okay, good.
So yeah, please, love to see the demo.
I've been an IntelliJ user since 2002, I want to say. So I'm.
Blimey. Okay.
Thanks, JetBrains. So yeah.
Yeah, I mean, it's certainly in the Java ecosystem. It is a very well loved piece of software. You're not alone. Although I'm slightly horrified by that time frame.
Yeah.
You're sort of there may be viewers who were born in that year. So
okay, showing my age, sorry.
But that said, I don't know how many 18, 19-year-olds are writing Java, but definitely some, and it's a great IDE.
Okay, so what I'm going to do is I'm going to kick off the process here, and then sort of explain a little bit why that's going on, because it just takes a little bit of time. So I've got a write tests button that kicks off the magic, and you'll see that sort of going on in the background as I talk. So the project I've chosen here is Spring Pet Clinic, which is also probably of that time frame in terms of age. So Spring Pet Clinic, if you don't know, is the kind of the demo application that the Spring guys use to show new features. It's very it demonstrates pets and vets, and going. I don't think we call them clinics in this country, but you go to the vet with your pet and have an owner. And so it's just a demo application geared around that, and it shows some of the features of Spring.
Well, it's something that people have come across as well. It's great to have a demo with a code base that people know.
Yes.
So yeah, certainly it is a well-known piece of software, and that's super helpful, I think, in terms of making the case.
Yeah, and so what I'm generating tests for is owner controller, which is kind of part of this sort of web MVC framework in Spring, what you'll see, just sort of note a few things. The configuration is driven by annotations. There's a few web type methods. I think there's 7 in total. It's relatively straightforward. And this is what we would term a unit. So we talked about units. This is a unit. It's a class that does something and needs a bunch of other things to work, but the focus is on this.
Yeah.
And if I just kind of have a look at the guys, the test the Spring guys have written, so this is only controller tests, what you'll see, just a few things to note here. So what you'll see is they're testing the unit, so they're what's called mocking out the pieces that aren't under test. So this is only repository and visit repository.
Yep.
They're doing a bunch of setup with fairly interesting looking data. So, first name is George. You don't want a first name of, I don't know, Wibble or Tree or so, it needs to be usable data. Similarly with telephone numbers. And then what you'll see is they've got small tests for each part of the functionality, testing both the happy paths, things working, and the unhappy paths where things break. And you'll see this code is very readable. They're using mocks. It's kind of, do this thing and expect this thing to happen.
Yes.
Asserting in the jargon. And you'll see that there's just a number of these. In fact, there are many more than there are actually methods that we're testing. And that's very much a feature of unit testing. Generally, you're doing it well, you're writing a lot more tests than you have methods that you're testing because you're testing different paths, as it were.
Absolutely.
So so I think this is an example of great tests. So I would say kudos to the Spring guys. They've written good tests here. They've used good frameworks, and it's pretty understandable. But I think you can also see that this is a bit of a skill. There is some. You need to be familiar with mocking. You need to be familiar with the sort of Fluent API that they're using here, and to get it to look like this. It requires some skill.
Yes.
So our products are now finished. So let's have a look at the test DiffBlue cover has written. So DiffBlue cover is a plugin that you install into IntelliJ, and you can download it from the IntelliJ store, and there's a free version for trial. So the test that we've written, you can see, is actually very similar. So we too are mocking out the pieces that are not under test. We're using annotations to drive the way the test is set up, and then in particular, we're using this kind of mock-based Fluent API to write tests that are understandable and mean things. So, we've intuited that. We've got a method name that means something here. We're pulling out pieces. We're providing data in a way that it's understandable. So I think if we flip on down a little bit, you'll see. Okay, so here's a test that requires some data. We're based in Oxford, so obviously we have to use Oxford-based data. Sorry about that. But again, you can see that the data is understandable. It's this is not just random stuff like you might get with fuzzing, for instance. It's actually data that makes sense for the application. And you can see that we've written a lot of tests here, probably a similar number to the Spring guys, testing most of the functionality. And just to prove this is real, I can just run these tests. So it's just building and running these tests, and they all just run and pass. So what we're doing is we are testing the way the program works. So essentially, we're analyzing the program. Is Java, so we can look at bytecode, we can look at methods and all the rest of it, and we're looking at the functionality of the program and providing data and setting up tests that enforces that functionality. So, if you'd coded this in a different way, then you'd generate different tests. But it's very much a reflection of what the program actually does and making sure that you're kind of testing that behavior. And so one of the nice things about this is developers can they can write the tests. If they don't like them, they can delete them. If they think they're testing something that actually is wrong, they can then change their functionality and regenerate the tests. And then I think the final thing to say is that these live in perpetuity. These are not kind of fire and forget. You can now check these into your version control system. When this code becomes legacy, the tests become legacy with it. And if someone needs to change the code in the future, they can, because the tests exist.
So the point you made about making legacy code more maintainable, once you run this as a process, you're in effect supporting and making your code more maintainable and supportable in future?
Absolutely. And actually, we can do this for legacy code as well. So we have a CLI version of this. So you can run as part of your CI system. So you could run it over your entire legacy code base and generate tests for that legacy code base, and so kind of make up the shortfall, as it were.
Awesome. So basically, you're going to automatically generate unit tests for the code that people are writing or legacy code bases, and just make life a bit easier in terms of test coverage.
Yes, indeed. And I think, it's putting control in the hands of the developers. It's not only letting them get on with things that they want to do, but it also is exposing what's actually going on. So, you as a developer, you may not have thought of the kind of things that this is testing or the behavior that is showing, and that's kind of being surfaced to you. So, and then finally, obviously, to say this is shifting left, which we sort of agreed is a good thing.
Okay, and so this is any kind of Java this will work with?
Yeah, any kind of Java, but particularly Spring. We're very focused on Spring projects, of which there is a lot out there. One of the nice things about Spring is that the annotations tell us a lot about intent. So we can sort of make inferences about what the code is trying to do and how it interacts in a way that's a bit harder with kind of raw Java. We can still do it for raw Java, but Spring gives us more information that makes that process easier. So this is just a summary. It's an IntelliJ plugin, free to use on open source projects, runs 100% locally. So one of the things that people are a little bit concerned about with this type of tool is, do I have to ship the code to you? There's a lot of security concerns over that sort of model. And the answer is no, you don't. So we can do this totally locally, no issue of IP leakage or anything like that. We'd be happy for you to download it and give it a try.
Great. Okay. Well, thanks, Andy. That's been great. Short and sweet. We don't always get that from the people on What Is How To, but it's definitely beneficial. So what is unit coverage, unit testing? How can you improve your coverage? This has been James Governor from RedMonk and Andy Piper from DiffBlue. And I'd love to hear any feedback from you if you try the tool, and let me know how it works. Let Andy know how it works. And certainly anything that improves testing and the reliability of the code that we write really has to be a good thing. So thanks again, Andy. And
thank you for inviting me, James.
Sure. Thank you.